Everyone must have seen bearings. It is not only ubiquitous in our lives, and 90% of mechanical systems cannot do without it. It can fix the rotating parts, precisely fixed in a specific position, in a controlled way, transfer the generated force to the bearing body or adjacent parts. At the same time, under the premise of ensuring movement, reduce friction to the lowest level. That's the bearing. In order to minimize friction, people have specially designed various bearings. From the structure and working method, bearings are mainly divided into plain bearings and rolling bearings. Let's look at plain bearings first. In plain bearings, the moving parts slides directly on the bearing surface of the bearing seat. A plain bearing. A common example is a door hinge. When the door is opened and closed, the pin shaft inside slides back and forth in the bushing so that the door can rotate. The essential problem of this type of plain bearing is the large sliding friction and limited lifespan. Rolling bearings don't let the parts rub against each other directly, but between the inner ring and the outer ring, a ring of rolling elements. These rolling things are called rolling elements. They can be balls, rollers, needles, cylindrical rollers, or tapered rollers. Different shapes correspond to different forces and working conditions. Next, let's look at rolling bearings. Let's start with the most common ball bearing. If the rolling elements are balls, then this type of bearing is called a ball bearing. Among all ball bearings, deep groove ball bearings have the simplest structure and the most widely used, and it is also the most common one in reality. Structure is very simple. The balls roll in the semicircular grooves of the inner and outer rings. This design is very suitable for bearing radial forces, so deep groove ball bearings are also called radial. Deep groove ball bearings. Since the ball and the raceway are in point contact, with small contact area and low friction loss, its biggest feature is fast. The rotation speed can be very high. Deep groove ball bearings are divided into two types, are mainly divided into open and dust-proof types. Let's start with the most basic metal dust cover. This dust cover is non-contact type, fixed on the outer ring, leaving a gap between the inner ring, so it hardly increases friction. It mainly protects against large particles of dust and splashing water, but its protection against moisture and fine particles is limited. If the sealing requirements are higher, nitrile rubber seals will be used. The gap between the seal and the inner ring is smaller, which can more effectively prevent moisture and small contaminants from entering. However, it should be noted that it may have slight contact, so it is called a low-friction contact seal. In addition, the deep groove ball bearings mentioned here, the balls are arranged in a single row, so it is also called a single-row ball bearing. When the carrying capacity of a single-row ball bearing is insufficient, a double-row design will be used. Double-row deep groove ball bearings have two rows. Two rows of balls are placed. Compared with a single-row bearing with the same inner and outer diameters, its width does not increase much, but the carrying capacity is significantly improved. It is very practical in situations with limited space and large loads. If the working conditions not only have radial forces, but also a large axial force, then angular contact ball bearings are used. The raceways of angular contact ball bearings. Therefore, it can withstand both radial and axial loads simultaneously. In a single row structure, you must pay attention to the installation direction, because it can only withstand the main axial force in one direction. To withstand both axial forces simultaneously, in engineering, two sets of angular contact ball bearings are used in pairs, or directly make it a double-row angular contact ball bearing. In double-row angular contact ball bearings, there are two common arrangements. One is back-to-back arrangement. The other is face-to-face arrangement. In back-to-back arrangement, the pressure lines cross outside the bearing, and the support points are pulled apart. This structure has high stiffness and is not easy to tilt. It is the most commonly used and most stable solution. When arranged face-to-face, the pressure line focuses closer. The advantage is that it is easier to compensate for misalignment, but the stiffness is lower and more prone to tilt. So, in most cases where high guidance accuracy is required, back-to-back arrangement is the preferred option. Let me briefly explain the assembly process of this double-row angular contact ball bearing. First, put the balls into the outer ring raceway, and then slide the inner ring in from both sides. The balls are fixed by the cage, by making the inner ring in two halves and loading it from both sides, which can eliminate the assembly gap, and more balls can be placed, further improving the carrying capacity. There is also a more special angular contact ball bearing, called 4-point contact ball bearings. Each ball contacts 4 points of the raceway simultaneously, so it can withstand bidirectional axial forces, but its mirror load capacity is limited. It is more suitable for applications with axial loads, because the outer ring and cage can be installed separately from the inner ring. This bearing is also called a non-self-retaining bearing. It is very advantageous when the installation space is complex. If misalignment is inevitable in the working condition, such as thermal expansion, shaft bending, or installation errors, Then self-aligning ball bearings are used. It has 2 rows of balls, and the outer ring has spherical raceways, which can compensate for about 3 degrees of misalignment. It is very suitable for occasions with limited shaft installation, but the ball is a point contact, with high surface pressure, when high radial load capacity is required, but the speed requirement is not high. Rollers are used instead of balls. These bearings are called cylindrical roller bearings. Its linear contact greatly improves the carrying capacity, but the axial load capacity is also limited, and it is sensitive to misalignment. If the rollers are made thin and long, it becomes a needle roller bearing. It can, in a very small space, bear high radial loads. It is common in gearboxes, universal joints, and compact mechanisms, but it cannot withstand axial forces, and it has very high lubrication requirements. To withstand both high radial and axial forces, cone roller bearings appear. Since the rollers are tapered, all imaginary extensions will intersect at a point on the axis. To achieve pure rolling, low friction, the axial load capacity of tapered roller bearings is related to the contact angle alpha, usually between 10 and 30 degrees. However, this bearing is extremely sensitive to axial clearance. It must be precisely adjusted, otherwise it is easy to heat and wear. The matched tapered roller bearings in sets have been set with clearances or preloads at the factory. Complex adjustment is not required during installation. It is very suitable for axles, gearboxes, and machine tools with high rigidity. To balance high load capacity and self-aligning ability, there is also a very important spherical roller bearing, also known as self-aligning roller bearings. Its outer ring is a spherical raceway, which can withstand huge radial loads, but also compensate for about 3 degrees of misalignment. It has both cylindrical holes, but also cone bore versions. Precise adjustment of the bearing clearance can be done. It's very convenient to install and maintain. In addition to single-row spherical roller bearings, there are also double-row spherical roller bearings. It can withstand higher loads. It is common in heavy machinery, vibrating equipment, and reciprocating motion systems. The bearings mentioned earlier mainly bear radial forces, are called radial bearings. Let's briefly take a look at thrust bearings. One-way thrust ball bearings can only withstand axial force in one direction, and cannot withstand radial forces, or compensate for misalignment. If you need to withstand bidirectional axial forces, a double-direction thrust ball bearing with a middle washer are connected to the shaft and the balls on both sides. But since the ball is in point contact, the bearing capacity is limited. In heavy load conditions, a thrust cylindrical roller bearing is required, or even thrust needle roller bearings. Its structure is flat, which is very suitable for axial space-limited occasions. But the surface processing of the shaft and bearing, with extremely high precision requirements. There is also a very special spherical roller thrust bearing. It can withstand huge axial forces, but also withstand a certain radial force. It also has self-aligning ability. It is common in heavy presses, ship propulsion systems, and large conveyor equipment.